The last of the properties specifically for parallelograms that we're going to look at is that the diagonals bisect each other. So looking at number 10, if the diagonals bisect each other, then I know that this line segment here, EA, is congruent to the other half of the diagonal from E to H. So since EA and EH are congruent, and we know EH is 5, then I also know that EA must be equal to 5. Well, the same thing happens on the other side. I know that EL is congruent to the other half of the diagonal, which is EW. And since EW is equal to 8, that means EL must also equal 8. All right, number 11. So now we're going to apply that same idea, but we've got some variables. So we're looking for MS, which is congruent to SA. These two pieces are congruent. Since they're congruent, we can set them equal. I can say 3x minus 7 equals 8. What should the length of MS be? Without even solving this, could we determine what it should be? We could, right? We could already say that it's going to be 8 because AS is 8. But we still need to solve for x, so let's keep working. When I solve this, the first thing I'm going to do is add 7 to both sides. And I get 3x equals 8 plus 7 is 15. Next, I'm going to divide both sides by 3. We get x equals 5. Now, we've already determined what MS equals, but it could be helpful just to double check our work. So I'm going to make sure that when I take 3x minus 7 and I plug in 5 for x, we indeed get 8. So 3 times 5 is 15, minus 7 is 8. So we did the check and we were right. Let's check out number 12. So in number 12, we first need to solve for x. I'm looking at NA, which is congruent to JA. Since they're congruent, I can set them equal. So we know JA equals AN. And I'm going to plug in what I know. So JA is 4x plus 2. And AN is 7x minus 13. And to solve these for x, I want to get all the x's to one side and all the numbers to the other. And so my strategy is always to move the x, that is the smallest. So 4x is smaller than 7x, so I'll subtract 4x from both sides. 4x minus 4x is 0. Bring down the plus 2. 7x minus 4x is 3x, and I'll bring down the minus 13. Now, to continue solving this, the next thing I want to do is get rid of that minus 13, and the inverse would be 2 plus 13. Add 13 to both sides. 2 plus 13 is 15, which equals 3x. All right, the next thing that we want to do is get rid of the 3 in front of the x. To undo multiplication, we divide. So 15 divided by 3 is 5. 3 divided by 3 leaves me with 1x. So we know x equals 5. Now, to use that information to find NA, we know that NA is equal to the expression 7x minus 13. We're going to use this and we're going to plug in 5 for x. So we get 7 times 5 minus 13. 7 times 5 is 35. Minus 13, I get 22.